Hello everyone, welcome to Vedantu JEE English. Again, I got disappeared. Oof, yes. Hello everyone, welcome to Vedantu JEE English. I am Diksha, your chemistry master teacher. So everybody, how are you all? How is your preparation going on? Very good afternoon, very good evening, all of you. So guys, in chemistry, right, I have revised all the theory parts, right? Just the questions of organic were left and we are doing it today, right? I have done it multiple times, but 2026 questions, especially I wanted to take it with you, right? So that's why I'm doing it today, right? Is it buffering? Yes, everyone, do tell me. Is it buffering? Is there any issue in video or audio? You can let me know. And today is practically the last day if you have your exam on 2nd of April. So today is practically the last revision day for you, right? But still, for tomorrow as well, I am conducting one small session of 30 questions. Just 30 questions I'll take. Approximately 8 questions from inorganic, 11 questions from physical, and 11 questions from organic, right? So tomorrow's session is going to be very important for you, and I'm going to take it at 12 p.m. right? In the afternoon, I'm going to take the session so that you get free by 2 p.m. right? So that you get free by 2 p.m. and after that you can, revise whatever you want to revise. Okay? Yes, everybody. Yes, NEET aspirants can also watch this session. Yes, everybody, tell me. Shall we start with the class? Shall we start with the class? But before that, do let me know how many of you have your exam on 2nd of April. How many of you have your exam on 2nd of April? Tell me. And what are the other students who have their exam on other dates? Also do let me know, right? So that I can, plan out something for you, right? And I hope so those students who have not watched yesterday's session in live, they will watch yesterday's session in the recorded version, right? Because tomorrow it is not possible for you to watch if you have your exam on 2nd of April, but today you can still watch it at 2x speed, you can watch it, right? Okay, chalo. Now let's start with the class. Now I want all of you to answer as well in the comment section, right? 50 questions are there. Give 1 mark for each question and tell me in the end how many questions you were able to get right. And most of these are 2026, some of them are 2025 questions, right? So I've tried to take new pattern here so that you know what they are focusing on and what, like, this will also relax your mind that okay, what they have asked in attempt 1 was not something out of the box, it was a general thing only that they were asking, right? Are you all ready? If you're ready for the class, then just spam the chat box with green hearts. Everybody wake up, right? Don't sleep here. Wake up. 8th, 4th, 2nd. That's great. Okay, so most of you have, like, very rare students are able to speak, huh? Lazy people out there. I speak something, I'll sleep here only. Just like, wake up, be energetic. Question answer we are doing. I want you guys to be energetic, and I know it is glitching. I know when it is glitching, so don't worry. I'll take care of that it doesn't get stuck. Right? Okay? Yes. Only Arts and Geeta and Jai, Chucky, Vijay, Abdul. Yes. Now, first question on your screen is identify the correct statements. One is the presence of NO2 group in the benzene ring is activating towards electrophilic, deactivating towards electrophilic. Then you have activates nucleophilic substitution, deactivates this, right? Now, firstly you need to know what is NO2 group. NO2 group shows -M and -I effect, -M being more dominating. So that means overall it is a deactivating group, right? Now, if I say it is a deactivating group, that means it is going to create less electron density. So the one which is nucleophilic, if a nucleophile is getting added, so see, electrophile is actually positive and nucleophile is actually negative. So to the less electron density, nucleophile will get attracted. That means it will activate the ring towards nucleophilic, and towards electrophilic substitution it will deactivate. Why? Because electrophile needs electron density, and electron density you have decreased, and that is the reason it will deactivate it here. So answer will be B and C. That is, answer is D is the correct answer here. So let me see. Very good, Shiva, Darshan, Uma, Padma, very good. Answer is absolutely correct. D is the correct answer. Now let's switch to the next question. Question number 2 is statement 1 and statement 2 you have here, right? Now my speed will be little fast, not that fast like a bullet train, but yeah, it will be still like a Shatabdi or Vande Bharat, right? So that we can at least finish this session in less time, because I know every single minute is important for you. So no this and that, just stay to the point. I am jumping. Now statement number 1 is there are several conformers for N-butane. Out of those conformers, you have this is least stable. Can you answer? For butane, there are 4 conformers: fully eclipsed, half eclipsed, that means partially eclipsed, gauche and anti. Anti is this one, right? And anti is the most stable. And this one is fully eclipsed. Fully eclipsed. And this is least stable. So this statement is correct here. Now, as the dihedral angle increases, torsional strain decreases from X to Y. Yes, everybody, tell me in the chat box. Yes, everyone. We are saying that as the, see from here what is happening here, theta, that means dihedral angle is 0. Here dihedral angle is 180 degree. So we are saying that here dihedral angle is increasing, absolutely correct. Torsional strain is decreasing. Yes, if you see torsional strain means the repulsion here. So repulsion here is very high. Here the repulsions are very low. So that means statement second is also correct. Answer will be D again is the correct answer here. Very good. Very good. Now let's see the next question. Correct order of stability for the following. Correct order of stability. Now we are going to talk about stability here, right? And here they have given carbon ion to us. Now carbon ion is which one? Money or stress? Carbon ion is like stress. When someone gives you stress, right? When someone gives you stress, you become unstable. When someone takes away stress, you become stable. So carbon ion is dependent upon electron withdrawing and inversely proportional to electron donating group. So here if you see, this one is, this carbon is having 3 sigma, so it is sp2. This is 4 sigma, so it is sp3. And this is 2 sigma, so it is sp. Electronegativity is of the order sp, then it is sp2, then it is sp3, right? This is the order of electron negativity. So that means sp has the maximum electron withdrawing effect. That is means sp is going to have maximum stability. So here sp is this thing, sp is this thing. So these 2 options are eliminated. After sp you need sp2, that means you need double bond here, and here you have single bond, so that is also eliminated. Here you have sp, then you have sp2, then you have sp3, which has the least electron withdrawing effect. That is why it has the least stability. So answer is going to be C is the correct answer here, right? Okay, very good everyone. Now let's talk about the next question here. A resonating structure with more number of covalent bond and less charge separation are more stable. Now they have given you 5 statements out of this, and I think so they will be asking the correct statement. I think it is not written here, so they are asking the correct statement out of this. Now tell me everyone, what is the correct statement out of this? Resonating structure with more number of covalent bonds and less charge separation are more stable. Covalent bond. Covalent bonding, we talk about pi bonds here, right? Okay. In electromeric effect, an unsaturated system show plus C with nucleophile and minus C with electrophile. Okay. Now, if you talk about electromeric system, that is this one, this system, right? So, if you have a nucleophile is going to attack here, right? Electrons are going to attack here. So, it shows with the unsaturated system shows plus C. No, it is showing minus C with nucleophile. Nucleophile is negative, no? So, it is jumping on different directions. If I talk about this kind of situation, then you have an electrophile here. Electrophile is going to attack on this position and electron also here. So, this is going to show plus C. This is going to show minus C. That is incorrect. Okay. Now, inductive effect is responsible for high melting point and boiling point and dipole moment of the polar compounds. Okay. High melting point, boiling point and dipole moment. Yes. The greater the number of alkyl groups attached to the doubly carbon, higher is the heat of hydrogenation. Wait a minute. If I talk about a nucleophile, wait a minute. Here, stability of carbon ion increases. I don't know if they're asking me correct or incorrect. That's what I'm guessing here. Stability of carbon ion increases with increase in S character. Because as the S character increases, here what was happening, this is SP because S character is more, that's why stability is more here, right? S character of the carbon carrying the negatives. The stability of carbon ion increases with increase in S character. If I say S character is SP, then SP2, then you have SP3, this has maximum S character. Right? In the carbon ion, the stability increases with increase in S character of the carbon carrying the negative charge. Carbon carrying the negative charge. If carbon is carrying the negative charge, then its S character will define the stability. That is not correct. The carbon next to the carbon carrying the negative charge will define. So this is the incorrect here. If I see, this will be incorrect, right? Greater the number of alkyl group attached to doubly bonded, higher is the heat of hydrogenation. That is correct. Because more the doubly bonded alkyl groups, more will be the alpha hydrogens, more will be the stability of alkene. If stability is more, then heat to break that bond and add hydrogen, that will also be more. So this is true. Right? Inductive effect is responsible for high melting, boiling point, dipole moment of the compound. Dipole moment we can say, but melting and boiling point no, right? So this will become false here because there are other factors also, right? Then in electromeric effect, unsaturated, this I am very doubtful about, but the first statement, resonating structure with more number of covalent bonds and less charge separation is more stable. So more number of covalent bond, this will make it false. So answer will be D will be there, right? So answer should be B also should be the correct in electromeric, and unsaturated shows plus C with a nucleophile. Nucleophile, let's say you have Cn negative, right? With Cn negative, it shows minus E, right? With Cn negative, if I see, this is C double bond O, this is any nucleophile will be attracted towards less and electrons will shift here. So it is attacking on two different points, right? So it should be minus E here, right? Wait a minute. It should be minus E. I think there is some typing mistake. Wait a minute. Wait a minute. Let me just see that if the statement is correct or not. I think there must be some typing mistake here, okay? So it should be, here it should be minus E, here it should be plus E, right? Okay? So this should be With the nucleophile, it is giving on opposite, so it should be minus C, this is plus C. Okay, then the statement this will be correct. Then we can say B and D is the correct answer here. Okay, chalo. Now let's see the next one. Let's move on from that question, right? So now let's see the next one. Arrange the following carbanions in the decreasing order of stability. Now decreasing order of stability, again this is the carbanion. If I say decreasing order, in the carbanion, more is the electron withdrawing, more will be the stability. Now I need electron withdrawing, here it is plus I effect. This shows minus M effect, right? And that is why that is deactivating. This shows plus M effect, that is activating. This does not show any effect, and this is also deactivating because of minus I, which is dominating. So that is why this is also deactivating. So I need deactivating now. Deactivating is this one is deactivating, and this one is deactivating. Here, because it is minus M, so that is more deactivating. So answer will be fourth is maximum, right? This you can eliminate. Then after fourth, deactivating is this one with minus I. So then after fourth, it will be 1. That is here. So this is also eliminated. After 1, again, if there is any deactivating, no. So that's why you will say which does not have any effect, that is benzene, right? That will be second. After second, you will have 2 activating, that is this is also activating, this is also activating. This is more activating because here you have plus M effect, mesomeric effect. So this will be least stable, this will be on the last part, and here you will have fifth. So answer will be D is the correct answer here. Okay, right? Done. Chalo. Next is, if you see the next question here, you have is more stable. We are saying this is more stable than CH3 as 9 hyperconjugated interactions are possible in this. Now, this is more stable, yes, because there are 3 alpha. If you talk about this thing here, this is having 3 methyl here. That means there are total 9 hyperconjugating structure. That is absolutely correct. That is why it is more stable. Here you have no hyperconjugating structure because no alpha hydrogen is there. No alpha carbon is there. Right? So we can say interactions are possible in case of this. This is more stable than this as 9 hyperconjugation are possible here. That is true. This is less stable than this as only 3 hyperconjugation interactions are possible in this. That is incorrect because here in this case there is no hyperconjugating structure. So answer will be B is the correct answer. Very good. You have clearly written it here. Right? Okay. Next is IUPAC naming of this particular question here. Now let's talk about this IUPAC naming. Okay. So IUPAC naming, they ask very simple questions on IUPAC naming. I have covered it in my GOC part a day before yesterday, right? So if you see this here, this is going to give ester, okay? So in ester, definitely there will be O8, O8, O8. It is alkyl alkanoate, right? So alkanoate part is the one that is attached to oxygen. So here this part is attached to oxygen. So this will be alkanoate part. That means 3 is, that means it is propanoate, right? So that means firstly eliminate anything which is apart from propanoate. This will be eliminated, right? Hexanoate will be propanoate, propanoate, that will be done, right? Wait a minute. Propanoate is no. Wait a minute. Alkyl alkanoate. Alkyl part is attached to oxygen as a substrate. My bad. The answer is alkyl alkanoate. Alkanoate. Right? So here alkyl part is attached to oxygen and this part is attached to C double bond O. Right? Okay. So if you see this here, right, in this case, you have, this will be your actually alkyl part only. This will be propyl part. Okay. This will be propyl part. This will be alkanoate. 1, 2, 3, 4, 5, 6, 7. that is heptanoate, right? So heptanoate I can see only here. And here you have N-propyl also, this is N-propyl. And if I name this, because alkenoate part is the parent chain, right? So this will be 1, 2, 3, 4, 5, 6, 7. So it will be 2 bromo is here, 5 methyl is here, N-propyl is as a substituent, so answer will be C. Okay, answer will be C is the correct answer here, right? Then they are asking you about isomers here. What about isomers? So in isomers, let's say you have 2-methylpropene and but1ene. So you have to draw these structures. 2-methylpropene means this thing, 2-methyl means here you will have methyl, and butene is this one. Now in this case you can see the parent chain is different, so they are going to be chain isomers. So A is 3, okay, A is 3, A is 3, A is 3 here, and A is 3 here, so these two are eliminated. Cis and trans are definitely stereoisomers. They are under the category of geometrical isomer. So B is 1 here, B is 1 in this case and this case as well. What about C? This is ether and this is butanol. This also has 4 carbon, this also has 4 carbon. So these are functional isomers, very simple, right? C is 4, that is functional isomers. So answer will be A. But1ene and but2ene. You have but1ene, one position, and you have but2ene. So these are position isomers, right? So D is 2, so answer will be A is the correct answer here, right? Good. Next, given below are 4 compounds. 4 compounds are given to you. N-propyl chloride, isopropyl chloride, secondary butyl chloride, neopentyl chloride. So these 4 isomers are given to you, okay? Percentage of carbon in the one which exhibits optical isomers. So there are 2 questions that they have asked you. First, they mix physical chemistry little bit with organic, right? So N-propyl is this thing, right? So there is no optical isomer. Isopropyl is this thing. CH3, CH3, this is Cl. Now in this case, again, there is no chiral center here. This carbon, chiral carbon means 4 different groups. So this is also not optical. This is also not optical. Secondary butyl means to one carbon, chlorine is attached to that carbon which is further connected to 2 carbons, right? To make it secondary butyl, I'll have to attach 1, 2, 3, and this should be like this, right? Okay. Chlorine is connected to that carbon which is further connected to 2 more carbons. Okay. So this seems like this is your optical isomer because this is the chiral carbon. So this is looking like optical isomer. What about neopentyl? Neopentyl means 1, 2, 3 methyl are as it is. This and this chlorine. So now definitely this is not chiral. This carbon is not chiral. This carbon is also not chiral because it has 2 hydrogens, 1 chlorine and 1 this part. So none of them is chiral. So this is also not optically active. So this one is optically active. Percentage of carbon in the one which exhibits optical. Now here what you have to do, how many carbons are there? If you see this is CH2. 1, 2, 3, 4 carbons. How many hydrogens are there? Percentage of carbon, 1 is optical isomers. Okay. So here 3, 4, 5, 6, 7, 8, 9 and this is Cl. So carbon is 4. You will write 4 into 12 plus molar mass of this whole multiplied by 100. That will give you percentage of carbon here. Okay. Right. So what you will do, first you calculate it. So what is the molar mass? How do you calculate the molar mass of this? 12 into 4 plus 9 plus 35.5. That's how you will calculate the molar mass. I can also give you the calculation here. Once you have done this, till here you know this is secondary, this is the optical isomer that you have. So it is C4H9Cl. Molar mass is, you will calculate it, it will come out to be 92.5. 4 into 12 is 48. So 48 by 92.5 into 100, that is going to be your answer. That is 52% approximately. That is C will be the answer here, right? Okay, that is how they mix organic with physical chemistry. Now let's talk about this question here, which is the number of optically active products from complete ozonolysis of given compound. Now see, complete ozonolysis means this will break, this will break, this will break. Okay, complete ozonolysis. So this will break to give us CH3, C double bond OH. Here also it will give us CH3, C double bond OH. That means two molecules of this will be formed plus. Here when this will be formed, this will give you C double bond O, C double bond O. This is H, C double bond OH. This is C, this is CH3, this is H. And this will be C double bond O, C double bond OH. Here also it is C double bond O, H, C, H and CH3, then C double bond OH, right? That means two of this will be there. Two of this and two of this you have. Now, is there any optically active? They are asking there is optically active compounds. Now you need to look for optically active means chiral carbons here. So this carbon is not chiral. This is sp2, so not possible to be chiral. This is also sp2, not possible. Here you have, here there was a possibility, but because this CHO and CHO is same, so this is also not chiral. So there is no chiral carbon here, no chiral carbon, or you can say no chiral center in any of the compounds. So answer is going to be 0. That is B is the correct answer here. Right? I got 0, ma'am. Yes, absolutely correct. Break the double bond, attach double bond. Oh, absolutely correct. Very good, Narsing, Kartik, Manoj. Very good. Hari, very good. Okay. Acha, now let's see the next one. The descending order of basicity of the following amine. Basicity always depends upon electron donating group. Tell me, the concept should click in your head. Electron donating group inversely proportional to electron withdrawing group. Now electron donating group, if I talk about, this is the electron donating, right? This is also donating. Now see one thing, okay? Lone pairs of aniline, nitrogen lone pair of aniline are already occupied in delocalization. So they are not fully available. So this will look afterwards. Firstly, let's see this nitrogen. This nitrogen is getting 2 plus I effect. This nitrogen is getting 2 plus I effect. This nitrogen is getting 1 plus I effect. So this has more plus I, this has more basicity. They are asking you basicity, na? Yes. So here E has the maximum. E has maximum. So this is eliminated. After E, you will have D. So this is also eliminated. After E, you will have D. Now these two are done. Okay. Now what about A, C and B? All of them are aniline. In aniline, you need donation. Here you have donation from plus M effect. Here you have no donation, and here you have minus M and minus I effect. Right. So I am writing M here because that is good for comparison. Here donation is there, so that means this is more basic. So after D you will have B, and after B you will have A, which does not have any effect, and after A you will have C, which has withdrawing, which will decrease the basicity. So answer will be B, that is 2 is the correct answer here. Right, everybody? Tell me. Clear? Next question is the least acidic compound among the following. Least acidic compound. Yes, everybody, least acidic compound. In acidity, you firstly take away the hydrogen here. This is negative. You take away the hydrogen, this will become negative. This will become negative, and here this will become negative. Right? Now see this thing. Least acidic. Clearly, na? Clearly this is the least acidic, because here what will happen? On the carbon which has triple bond, you have, this is COO, ET, right? On the carbon which has which is sp hybridized, you have negative charge. This will destabilize it. This is electronegative and you have negative charge on that carbon, which is not a stable thing. On a sp hybridized carbon, having a negative charge is not stable. So here that is why least acidic is going to be D, that is B is the correct answer here. Right? Okay. Next question. Next is, consider the following compound most stable and least stable carbon radicals respectively produced by homolytic cleavage. Homolytic means one electron here, one of carbon corresponding to CH. Okay. So corresponding to this, first you will have to look for most stable. See, most stable is when this CH bond here will break, it will give one electron here, this will become free radical. So this is conjugation, pi bond, single bond and then free radical. So here what will happen? They will start resonance here. That is why second will be the most stable. In all the other cases, there is no conjugation, so second is the most stable here, right? Now, least stable is, I told you, when on a triple bond carbon, you have negative charge or positive charge or free radical, that becomes least stable. So here if it loses, when one electron will go here, one electron will go here, what will happen? This free radical is not going to be stable, so one is going to be least stable here. So this is least and this is most. So most is 2, least is 1, so answer will be D for Diksha ma'am. D is the correct answer here, right? Okay, now let's talk about next question here that says, on nitration of metaxylene. Metaxylene means here you will have, on the benzene you have one CH3 and one CH3 here, that is metaxylene, right? With HNO3, that means nitrating mixture we add here. So nitrating mixture is actually, this is ortho para directing and this ortho position will not be attached here, right? So this ortho position, if this is the para position, this is the ortho position. Here this ortho position is equivalent to this ortho and this, see, this position is para for this one and ortho for this one, and this position is para for this one and ortho for this one, right? So you can choose any of this, right? Then they are saying followed by oxidation. You can choose any of this, answer will be same, okay? You choose this point or this point, answer will be same, right? Because these are equivalent to each other, right? So let's say I choose this one, right? Then followed by oxidation. Now I have to do oxidation as well. So on the benzene ring, whenever you have alkyl chain, that is converted to COH, right? This will be converted to COH. Now the answer is 4 nitrobenzene 1 3. See, if I start from here, this will be, if I start from here 1 and 2, then 3 4 5, this will get fifth number, which is not correct. I have to give minimum number to both of them. So I can't say that I have to give my substituent a very good lowest number, then I will start like this 1 2, wrong. You will start it like this 1 2 3. Now in this case, both the carboxylic acid are getting least number possible. So 1 2 3, this is 4 and this is 5, this is 5 and this is, or you know what you can do here, though you are getting 1 2 3 4, you can also do one more thing here, even less number. If you do 1 2 3, now this will also get fourth, instead of 6 this will get fourth number. So that is absolutely correct. 4 nitrobenzene 1 3 dicarboxylic acid. Dicarboxylic, why carboxylic? Because whenever on the ring it is carboxylic acid, not oic acid, right? So this is correct, right? This statement is correct. CH3 group is ortho-para directing, that is correct. NO2 group is meta-directing, that is also correct. So both the statements are correct here, right? So answer will be B is the correct answer here. Both the statements are correct, okay? Now next question here. Let's see, let's talk about this question everybody. Let's see. let's do this question now. Let's see. So the correct stability order of following species or molecules is what? Correct stability order which we are talking about. So if I talk about correct stability order here, this will be 1, 2, 3, 4. This is negative, no? So 4 pi electron is anti-aromatic, least stable. 1, 2, 3, 4, 5, 6 here. So 6 pi electron means aromatic here. This is 1, 2, 3, 4, 5, 6, 7, 8. Ma'am, 8 pi electrons, anti-aromatic. Is it correct? No. Why? Because it has a tub-like structure. I told you so many times that 8 aniline, 10 aniline and 12 aniline are non-aromatic. 8 is non-aromatic because of its tub-like structure. So this is non-aromatic. Answer will be Q is maximum stable. After that you have R. Q, then R, then P. So answer will be A is the correct answer here. Is that clear, everybody? Okay. Now let's see the next one here. That is correct order of basic strength. Oh my God, I just got freezed. Okay. Thank God I see it the correct time. Otherwise, I would be crying here. Right? Just imagine you do your whole JEE exam and then someone says that the sheet is not correct from where you have marked the answers. You will be like, what? What you are saying? My hard work is like wasted. Thank God I just saw it. Yeah, okay. Now let's see. Ma'am, I can do more questions in G. I can do. Yes, you can do. Definitely, you can do. You will do. Right? Don't lose your confidence. Right? That matters a lot. So, correct order of basic strength in pyrrole, pyridine and piperidine is what? Yes, everybody. Tell me correct order of basic strength here. Yes, students, everybody, I think this you can easily answer. This is like one of, like I have done this question like multiple times, right? This is 2024 question. I did it last year as well, right? I told you. So I feel like you should know this question because this is not a new question for you. Correct order of basic strength. First is here the electrons are involved in delocalization. So availability is less because here they are involved in delocalization. So pyrrole is definitely the least. Okay, so this 2 cannot be the answer, 4 cannot be the answer. Out of piperidine and pyridine, both the electrons, this electron is also not involved in delocalization, here also not involved. But here it is sp3 hybridized nitrogen and here it is sp2 hybridized nitrogen because here you have 2 sigma and 1 lone pair, so this is sp2. Now we know that sp2 is more electronegative. It will not let the electrons go anywhere. So availability will be less as compared to this. Here in case of p-pyridine, it is sp3 hybridized. The nitrogen is not so clever. It will be like, okay, you want to take electron, take away from me. It's okay. I am a very good person. I can donate my electrons. I am not that clever here. Right? So that is why answer will be pyridine, p-pyridine, pyridine and then pyrrole. So answer is A is the correct answer here. Okay. Next question. For the given compounds, the correct order of increasing pKa value. Now see, Ka value is inversely proportional to pKa value. That means now you have to look for firstly the order of Ka. Okay, the order of Ka, guys, you have to give, and then opposite will be the order of pKa. Right, opposite will be the order of pK. So now I'll have to see that where which factor is applied. All of them are phenol. So here on phenol at the meta position, minus M and minus I is applied here. Right, first I'll write all the factors that are applied where minus M is dominating. On the meta position, only inductive effect is applied, so this will be only minus I. On the para position here, again minus I and plus M is applied. So it is plus M also is applied, which is dominating, then minus I in case of OCH3. Now at the meta position, again only the inductive effect is applied. Mesomeric effect is not applicable on meta positions, right? So now if I see the value of acidity, the Ka value depends upon electron withdrawing group. If you have electron withdrawing power, because it depends upon the stability of carbon ion, right? So if carbon ion stability depends upon electron withdrawing, when you take away the electron, it gives more stability. So I'm looking for electron withdrawing here, right? So here I can see two electron withdrawing effects are applicable. Here only one and here only one is applicable. Wait a minute, this is also minus I, that is also minus I, yes. So here maximum is available, so I can say B, right? Now here you have minus I and here also you have minus I. But electron negativity of oxygen is more, so this will have more minus I effect. OCH3 has more minus I or nitrogen NO2 has more minus I effect as compared to OR, right? NO2 has more minus I, that is in the table of this minus I, right? So this has more minus I, so it will be D here, right? Then after D you will have C, because this is also minus only. Then you will have C, right? This is B, this is D, this is C, right? Then I will look for plus effect here. Plus effect is here, but here you have no effect. So this is C, this is A, and this is D here, right? Here options are incorrect, okay? Options are, some gadbad is there in the option, because the order is supposed to be this. C, then A, because this still has minus now. As compared to this still has minus. There is no effect. So this will be more acidic, because at least it has some minus effect. It does not have any effect. So this is A. And after A, it will be donating. That is going to be least. So answer will be this. So pKa value will be BDCAE, right? So BD, this is supposed to be now. I'm just correcting it here. This should be CA, okay? Maybe there is some typing mistake, right? Maybe something like that will be there, but it should be this, okay? So answer will be BDCAE. That is B is the correct answer here. Okay, just remember this thing, they have given it to be wrong. Actually, order should be this. So clearly, this has minus, this does not have minus effect. So definitely, this is going to be more dominating, right? Okay, more acidic, right? Okay, now next is, so that's why I'm also deleting this part here, right? Sure. Now next is the total number of stereoisomers possible for the given structure. So there is this given structure, the total number of possible isomers, stereoisomers. So if you see this is the state of GI exists. This is the state of GI, right? And is there any chiral carbon here? If you see the chiral carbon, this Br is different, this hydrogen is different. This is one CH2, this is again double bond only. So this particular is the chiral carbon. So N is going to be 2 Gi plus 1 chiral, that is 3. So unsymmetrical this is, so stereoisomer is going to be 2 raised to power N, that is 2 raised to power 3, that is 8. So answer is C is the correct answer here. Some students are giving answers like very quickly, so that's very good, right? That's pretty good. Now let's see the correct arrangement for decreasing order of electrophilic substitution for the above compounds. See, electrophile is getting attacked. Electrophile means it is looking for electron density, right? It is electron loving, it is looking for electron density. When something is looking for electron density, that simply means we are looking for compounds which has more electron density, right? So more electron, this shows plus I effect, and this shows no effect. This shows plus M effect here, very good. This shows minus I effect, and that through 3 fluorine atoms. So that's why we can say this here, that this has maximum electron density, that is third, right? Third has maximum. Then after third, you will have first here, right? Then after first, you will have second here, and after second, you will have fourth, which has withdrawing effect. It will decrease the electron density, and hence electrophilic attack will be less. So answer is going to be B is the correct answer here. Next question, guys. Next question, that is based on aromaticity. Correct order of stability of carbon ion. So in this case, directly we can see this is stability, aromaticity based question. So what you can do, you just apply BRHI here. Back bonding is nowhere. Aromaticity, we can see here you have 4 pi electrons, so it is anti-aromatic. This is non-aromatic because no complete conjugation, non-aromatic. This is 1, 2, 3, 4, 5, 6. This is 6 pi electrons. This is aromatic. So D is going to be more stable, right? These two are eliminated. After D, and A is going to be least stable. A is least stable here. So answer is going to be A. D, now among C and B, which is going to be more stable? See, always remember that 5-membered ring is more stable as compared to 4-membered ring. That is why C is greater than B here. So answer is A is the correct answer here. Right? Okay, everybody, tell me. Clear? Done? Next question. Tell me the answer. Consider the following reaction of benzene. Very amazing question. Interesting question. See this. Aldol condensation also, they have asked multiple questions based on that. And after that, they are asking you to calculate the percentage. It's a lengthy question, okay? So see this. So you have benzene, you have attached this thing CH3, CO, CH2, CH2, CO, Cl. That means this is going to be the, this is going to be the electrophile that will attack here. So in this case, P is going to be what? P is going to be on benzene. You have a compound that is, this is C double bond O, then CH2, then you have CH2, then you have C double bond O, then you have CH3. Now see this thing very carefully. This is aqueous NaOH and heat. Now aqueous NaOH and heat, when you have this reagent on the carbonyl carbon, especially if you have 2 carbonyl carbon, then definitely this is going to be aldol condensation. Just see if you have alpha hydrogens here or not. So this is nothing but they are talking about aldol condensation. This is where most of the students must, will get stuck that what is this reagent. Then even if you know the reagent, forming the compound is itself a task here. Now I told you one trick here, that this is alpha. This alpha has this cannot be alpha hydrogen because this is sp2. This can be alpha hydrogen, or this can be this carbon has 2 alpha hydrogen. So the carbon which has more alpha hydrogen are more prone here, right? So this carbon, I will take the carbonyl carbon, right? And here this will be alpha, right? Wait a minute. If I take this, I'll take this carbonyl carbon and I'll take, wait a minute. One carbonyl carbon we will take. If I take this carbonyl carbon, right? This alpha you cannot take, right? Okay. I am looking for that if you make 4-membered ring, that is less stable, 5-member ring is more stable, 6-member ring is even more stable. So you'll have to see which membered ring you are able to form. If I take this carbonyl and then this alpha, then it will make 1, 2, 3-membered ring, which is not at all stable. Okay. If I take this carbonyl and I take this alpha, then 1, 2, 3, 4, 5. Now I can see maximum I can go here, right? So what I'll do, I'll take this carbonyl and I'll take this alpha here and I'll connect these two and I'll connect these two. So now let's see what we will have here. Answer will be, this is benzene here, right? and here you will have this carbonyl, which is when you attach these two things now, you will attach it with a double bond. I told you yesterday that carbonyl carbon and alpha carbon, directly the trick is attach it with a double bond. You attach it with a double bond, this will be CH2 because one alpha is gone. This C double bond is as it is, and this will be CH2 and this will be CH2 here. So it is going to be 1, 2, 3, 4, 5. 5-membered ring is there. This is going to be your total answer here. Now they are asking you percentage of oxygen here. Percentage of oxygen. Oxygen, how many oxygen? You have just one oxygen. Total molar mass here, right? That will be divided here, right? So percentage of oxygen is what? This will be the total molar mass that you will calculate from here, right? While calculating the total molar mass, remember this is one hydrogen here, one here, one here, one here. So the formula will become 1, 2, 6 carbon, 7, 8, 9, 10, 11. 11 carbon here. How many hydrogens here? 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. Is it? Yes. Hydrogen is also 11. And oxygen is 1 here. Wait a minute. Let me just verify this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 5. Wait a minute. This is 5. This is 6, 7, 8, 9, 10, 11. 11 only it is becoming. So it is C11, H11 oxygen, that is coming out to be the formula here, right? And out of that formula, you will just look for the percentage. You can calculate, you will get the molar mass as 157, right? And answer will be 10%. Total molar mass only you have to divide it with, right? Now let's see the next question here, that is the cycloalkene on bromination consumes 1 mole of bromine per mole of X. Now they are saying that cycloalkene, there is some cycloalkene, we don't know what is that cycloalkene. They are saying on bromination consumes 1 mole of bromine per mole of X. If 1 mole of X, see, if 1 mole of X consumes 1 mole of bromine, it means 1 double bond is there. It means 1 double bond is there, right? It means only 1 double bond is there, right? Gives the product. Now we are saying carbon ratio bromine. Let's say the carbon, I am taking it as C. Ratio bromine. Bromine, how many bromine you have? 2 bromine will be there, right? 2 bromine will be there. Why? Because when 1 double bond will break and 1 bromine molecule it is consuming, it will give rise to this thing. So that means carbon ratio bromine. Carbon, we don't know how many carbon in that alkene because it is looking as cycloalkene. There is no number that is mentioned here. So carbon, let's say it is carbon C, and bromine is 2 here for 1 molecule. 1 double bond is there, so 2 bromine will be there after the addition of Br2. Now that is given to be carbon ratio bromine. They are saying carbon ratio bromine is nothing but 3:1. So we can say carbon will come out to be 6. That means if carbon is 6, that means we are talking about cyclohexane, and that's it. Cyclohexane you are talking about. So now they are saying that the percentage of bromine in this percentage of bromine. Now bromine, you will write 2 bromine will be there. The mass of 2 bromine divided by the total molar mass of that compound, which cyclohexane is C6H12, and it will be converted to C6H10Br2, right? So here you will have 2 into molar mass of Br2 divided by molar mass of C6H10Br2 multiplied by 100, and that is going to be your correct answer here. Is that clear? That's how you calculate it. This is why I told you how to calculate this thing here. Rest is you just need to calculate the molar mass of C6H10Br2, that will come out to be 242, and the mass of bromine is 2 bromine is 160, that is 1 is 80 into 2 160, and that's how you will get your percentage of bromine here. Right, everybody? Now let's see the next question. But2-ine and hydrogen are separately treated with PDC, and this to give products X and Y. Two products it is giving X and Y. So they are saying that, they are saying here, see, this will give you cis-alkene, cis-butene. This will give you trans-butene. So now they are saying X and Y are stereoisomers of each other. Yes, they are stereoisomers, that is correct. Dipole moment of X is 0. See, trans is 0, X is not 0. X means cis. Cis does not have 0 dipole moment. This is false. Trans has 0 dipole moment. Here mu is not equals to 0. Here mu is equals to 0. Okay? Acha. Boiling point of X is higher. Cis has higher boiling point than trans. See, symmetrical is trans. So, trans will have higher boiling point. X and Y, melting point of trans is higher. Melting point of trans is higher, boiling point of cis is higher. That is correct. Okay. Melting point of trans and this of cis is higher. Then we say X and Y react with this to give different products. Different products. No, it will not give us different products. It will give us same products only. See, if you have cis now, so it will be CH3, CH3. This is H and this is H. Both of them are going to give you acetaldehyde, right? So this is also false. So answer will be, they are asking you incorrect or correct statement here. Incorrect statement here. B and D are the incorrect statements here. So answer will be A is the correct answer here. Right, everybody? Now let's see the next question. Consider the following. Consider the following. Now they are saying consider the following reaction. This reaction is given to you. In this reaction you have NaNO2. What is the role of NaNO2? NaNO2, what it will do, it will take out bromine from here, hydrogen from here, again bromine from here, hydrogen from here, and it will form 1, 2, 3, 1, 2, 3, and here you will have the triple bond, right? Here you will add NaNO2 again. Okay, if you again add, this will become, this is CH now. If you again add NaNH2 here, so this will become Na. This will become Na, right? So I'm just writing it here. This will become 1, 2, 1, 2, 3. This will become CNA, right? Positive. Now if you see, this is here. Then after adding this, you are adding this alkyl. So this R part will be attached here. That means this will become, wait a minute. So I'm just drawing it here. This will become, this is C, and here you will attach 1, 2 methyls. Okay. This thing will be done. So now they are saying this product Y. This is called as product Y. Okay. This is the product Y. This product Y has, what is the name of this product Y? So 1, 2, 3, here also 1, 2, 3. So I'll talk from here, 1, 2, 3. Aha, this is not 2 here, wait a minute. 3 carbons are there, na? So 3 carbons are there. 3 carbons are there. So 1, 2, 3, 4, 5, 6. So 2-methyl hex 3. 2-methyl hex 3-ine, right? Isopropyl butane, so it will not be 2-methyl hex 3-ine. I think answer yes. Answer is 2-methyl hex 3-ine. Okay? Tell me. Again chit-chatting. What it is going to give you? Tell me. Who will chit-chat with you in the exam? No one. Everyone will look away from you. So isomeric hydrocarbons, negative Bayer test. They are saying there is some isomeric hydrocarbon which has isomers. It is going to give you negative Bayer test. So Bayer test is negative. That means there is no double bond that is there. Unsaturation is not present. So total number of isomers from which 4 different non-aliphatic. Now I'll just give you this important information here, right? See, wait a minute. If I talk about negative Bayer test, it is given by alkane or aromatic hydrocarbon. Okay. Now see, alkane is not possible because alkane can never have this formula. For this formula, this is not possible. That means definitely aromatic hydrocarbon is there. And that's how you will have this as your, wait a minute, you will have this as your answer here. Right? Till now, we have not concluded the answer. There is benzene, that is C6H6. Right? Now in this you have to add 3 more carbon. 3 more carbon can be added like with 1 propyl, that is 1, 2, 3. You can have isopropyl. This is simple N-propyl here as the substituent. This is N-propyl as the substituent. You can have isopropyl as the substituent, right? These are the only 2 possibility with propyl. Now with 1 methyl and 1 ethyl, you can have this next to each other at ortho position to each other, meta position to each other, at para position. Then you can have 3 methyls. 2 or 3 are next to each other. They are symmetrical with each other, or 2 are together and 1 is 1 distance apart. Now they are saying that you have to tell me the total number of isomers from which 4 different non-aliphatic substitution sites is there. That means I have to see any site that is empty which can give you different differences. So 4 empty sites we need. Here we have 1, 2, 3, 4, 5 empty sites, so that we don't need. We are looking for 4. Here you have 3 empty sites, so this is also not possible. This has 4 empty sites, this has 4 empty sites, and this has 4 empty sites. But look at this. Here, if you substitute here and here, here it will give you different answer. Here it will give you different. Here it will give you different. Here it will give you different. In this also, here it is different. Here it is different. Here it is different. Here it is different. But if you look for this one, here and here it is same, and here it is same. So this is also not possible. This one and this one gives you 4 different aliphatic substitution sites. Okay, so answer is going to be 2 is the correct answer here, right? Okay, so answer is going to be 2 is the correct answer here. Now let's see the next question, that is the reaction which cannot be applied to prepare an alkene by elimination. We can't prepare an alkene by elimination, that is what? So here you have, see, in case of aqueous KOH you can't prepare alkene. This is again, here also you can prepare alkene. In this case, in the case of copper also you can prepare alkene. In the case of NaOH with this, here also you can prepare alkene. This will not give you alkene. This will also give you benzophenol. So this is also not possible. So in the case of this here, what will happen? Br will be substituted by OH. So that means B and D you cannot prepare alkene. So answer will be B and D. So answer is D is the correct answer here. Okay, answer is D is the correct answer. Let's look for the next question here. Let's look for the next question, guys. That is, you have, tell me what is the name of this reaction? What is the name of this reaction? What is the name of this reaction? This is a reaction where you have, this is double bond alkene and this is peroxide. Acha, see, when you have peroxide, the reaction proceeds, this is anti-Markovnikov addition, proceeds to most stable radical intermediate. Tell me guys, most stable radical intermediate. Yes, everyone, tell me, everybody. Tell me which one is the correct answer. Most stable radical intermediate, free radical mechanism we follow, most stable radical intermediate is there. Role of peroxide is to generate H free radical. Is this the role of peroxide? No. Right? During this reaction, benzene is formed as a byproduct. That is correct. 1-bromo-2-phenyl, this is formed as minor product. See, here anti-Markovnikov addition means OH negative part will be attached here and H will be attached here. That means 1-bromo-2-phenyl ethane will be formed as major product, not minor. So this is also incorrect. This will be major product. Same reaction in absence of peroxide proceeds via carbocation. That is correct. That's why it gives you Markovnikov. So answer will be A, C, E is the correct answer here. So answer is C is the correct answer here. Next question, everybody. Consider the following compound. So they have given you this compound here and they are saying arrange the compounds in the increasing order of reactivity with nitrating mixture. Nitrating mixture means NO2 positive will be the electrophile here. So that means electrophile means you need more electron density. Here you have minus M and minus I. Here you have plus M and minus I. Overall it is deactivating. Here it is plus M and minus I. So this C is going to give you the maximum here. Why? Because in the case of C, electron density is high, so nitrating mixture can attack here easily. Then after C, you will have A because that is deactivating plus less deactivating as compared to B. So C, A, B, that means D will be the correct answer here. Okay. Right, everyone? So answer is D. Okay, next. The correct order of rate of reaction of the following reactants with nucleophile. With the nucleophile by SN1. SN1 means what? Two step, that means carbocation stability we are looking for. So carbocation stability is where, guys? Here you have maximum because this will give you 3 resonance. This will give you 3 inductive effect. 3 plus I effect of CH3, that is here, here and here. Here if you take out, this is positive, this is bridgehead which is not stable, this is also bridgehead, this is also not stable. So answer will be 4, then you will have 4 will have maximum, then you will have 3. 4 and after that you will have 3. But what about these two? Now tell me what is Brett's rule. Tell me guys what is Brett's rule. Anybody here, what is Brett's rule? Brett's rule says that on the bridgehead position, sp2 hybridization carbon is not possible. So here positive charge is not possible. So both are unstable. But in this case, which is least stable, because here, yes, it is unstable, but here at least you have 2 bridgehead carbon to give it more plus I effect, so that this can get little bit stable. Both are dying only. This is living for 5 years, this is living for 10 years, right? Sorry, this is living for more years, that means 10 years. So this will be more stable as compared to second. So answer will be second is least stable. So answer is B is the correct answer here, right? Bacha, I will do for VIT triple E. Don't worry, I'll do everything. I'm here only. So don't worry about that. Okay. This one we have done. Now let's see the next question. Now here we have, please focus, right now the focus should be here, okay? So now they are saying 2-bromopentane alcoholic QH you have, what is the major product? So if you have alcoholic QH, this will be eliminated, and out of this will be eliminated. You will have a double bond here, that is this structure will be formed. Now you add Br2 here. When you add Br2, this will give you this Br here and one Br here, right? Anti-product will be formed. Consider the above sequence of reaction. 151 gram of bromopentane. How much? 151 is made. Is made to react. Yield of major product P is 80%. Okay, Q is 100%. Okay, see, they are saying that if I say this is 1 mole, right? One thing is they are saying that here mole concept is applied. If this is 1 mole, then this will be 80% and this will be zero point 0.8 mole. And if I react this with Br2, it is 100%. That means 100% of this will react to give this one. That means here it is going to be zero point 0.8 mole only. So in these two cases, it is zero point 0.8 mole only, right? Now they are saying 151 gram of this is used. So I will see what is the molar mass of this, and then I will apply unity method. That 1 mole is giving you how much? 0.8 of Q. 1 mole of compound is giving you zero point 0.8 of Q. Then the number of moles that I will get here will give you how much mole. Then I'll calculate the moles of Q. Then I'll multiply it with the molar mass. So let's see what is the moles of, what is the molar mass of this. Molar mass of, firstly I'll calculate the molar mass of this. Oi hoy, wait a minute. Wait a minute. 0.8 now. Directly also you can do this. In fact, yeah, that is true. Directly also you can do this, right? So this is how much? 0.8. So you can just directly say here 0.8 number of moles is equals to given mass by molar mass. So given mass is equals to number of moles into molar mass. So number of moles is 0.8, and here molar mass of Q, when you calculate it, is coming out to be 230 here, and that's how you will get your answer as 184 gram as the correct answer here. Right, everyone? Now let's see the next question here, that is 1,2-dibromocyclooctane. It reacts with KOH alcoholic, NaNH2, Hg and zinc amalgam, and what it gives you. Okay, so 1,2-dibromocyclooctane, cyclooctane is this one. Okay, 1,2-dibromo is this thing. When it reacts with alcoholic KOH, it gives you this thing here, that is double bond here. Then it reacts with NaNH2, 1,2-dibromocyclooctane, right? Then it reacts with NaNH2. Acha, alcoholic to dehydration is there, right? Okay. Then it reacts with this and this. Acha, chalo. This I'll give you. Wait a minute, guys. Wait a minute. Options are too small. But just give me a minute. I'm just getting some important calls. Just give me 2 minutes, okay? Okay. So now let's talk about this. Yes. So what you have here, 1,2 dibromocyclooctane, you add KOH alcoholic here. That means dehydrohalogenation is going to do. Wait a minute. I'll just draw this here. This will be like this here, right? This is one bromo and this is second bromo. This is one hydrogen here, this is second hydrogen. So when you add alcoholic OH, one bromine and one hydrogen will leave. When you add another NaNH2, one bromine and one hydrogen will leave, and it will give you 1, 2, 3, 4, 5, 6, 7, 8, and this is triple bond it is going to give you. Now in this triple bond, you are going to add H2, Hg2 positive. That means this is Kirchhoff's reaction. Okay. So in Kirchhoff's reaction, what you will have, 1, 2, 3, this is 1, 2, 3, 4, this is going to happen. This is OH, right? Now this is further going to get converted to enol, right, by tautomerism. So we'll do tautomerism, this will be converted to enol. Now after this, when you add ZnHg, that is Clemmensen reduction, Clemmensen. So Clemmensen is going to reduce it to cyclooctane, because double bond O will be converted to CH2. So answer will be C is the correct answer here, right? Okay, understood? Yes, everybody? So in the following series of reaction, definitely identify the major product A and B respectively. So now if you see the major product here, so first thing is, when I add here, this is Br, when you add SO to SO, SO3H will be added, and this is a ortho para directing, so on the para position SO3H will be there. Then after that you add Br to Fe, then again you add Br2 here. So this, students, this is going to be SO3H, this is SO3H, and this is Br. This is going to be meta directing, right? So in meta directing, this will give here, and this is ortho para, so this will give here and here. So Br will be here, Br will be here. Now they are asking you in the following series, identify the major product A and B here. So A is this and B is this. Now we'll have to look for the options here. A is this. Okay. None of it is matching. Wait a minute. None of it is matching. So we can hit and trial here, okay? So we can just do hit and trial here. Just give me a second. Let's do hit and trial here. Because if I see here SO3H, okay, that will be either on the ortho or para position. Para being major, more stable will be the major product. Okay. So this thing is already eliminated. This thing is also already eliminated. Now if I see I add Br to Fe, that means Br positive again I am adding. Acha, I have added it on the ortho. Wait a minute. Okay, I have added, they have added one Br2. So there should be, I have added on two places, I have added Br2. You can add just one Br2 here. That depends. Even if they had this in the option, I would have answered this. But here this was in the option, so I will answer this. So this is more applicable because for this it is ortho, for this it is meta. So answer will be B is the correct answer here. Right, everybody? Okay. Next is identify the products A and B respectively in the following reaction. In the following reaction, identify products A and B. Okay. A product is chlorobenzene. Now this we can see here by Dow's process, it has been converted to phenol. On phenol, when you add this Na2Cr2, this gets converted to benzoquinone. So answer is simple, phenol and benzoquinone is the correct answer. That is B is the correct answer here. So you can see in 2026 the level has slightly increased. Instead of, now if they ask you the same question, instead of asking this, you know what they will ask you? Question will be same. In the end, they will give you calculate percentage of oxygen. Then you will say 2 into 16 divided by molar mass of this compound B multiplied by 100, and that is going to be your answer. So the way of asking the question now has changed. Okay, so see the pattern difference. It's not like questions have changed. Questions are same, only they have just added little physical chemistry into it, right? Or there may be statement based question. Most of it is like that. Now next question is, consider the following reaction. Compound X is given to you. Let's talk about that. Let's talk about that, everybody. So they are saying that compound X is there where 76.6% carbon, this percent hydrogen, this one the vapor density. Okay. You know, the one who has done enough practice can easily answer what is this. The student who has gone through reaction, he doesn't even need to look for this thing. He doesn't even need to calculate all of this. You know what? Why? Because if you see this here, this must be phenol. Because you know what? This CO2 NaOH, I can clearly see they are talking about coal-based reaction. So only then it can become. Now you have other things to verify. Compound Y develops characteristic color with FeCl3. Yes, salicylic acid has that. FeCl3, it is shown by this ferric chloride test. Identify the incorrect statement from the given. Compound Y will dissolve in NaH. This is acidic, so it will get dissolved and evolve a gas. That is true. Compound X is more acidic. No. This is carboxylic acid, COH. So this is more acidic. That is false. So incorrect statement we have. So the question was seeming out to be tough, but if you've gone through enough practice, then you clearly can see it from the reagent, and this is coal-based reaction. If you have not gone through reactions, then you'll have to verify this from empirical formula. You'll firstly calculate molar. You know how this will be done. If you don't know how to guess, then it will be very lengthy question. First you will calculate molar mass, then you will calculate the empirical formula, molecular formula, then you will guess that this should be the compound. Directly here you can see it is coal base. Both compounds X and Y dissolve in NaOH, that is correct. Phenol and now both compounds are will burn with both the compounds will burn with sooty flame, that is also correct. So answer is B is the false one here, right? Next is a hydroxy compound. There is some hydroxy compound X with molar mass 122 is acetylated with acetic anhydride using large excess of reagents, ensuring complete acetylation of all hydroxyl groups. Okay, they are saying we don't know how many hydroxyl groups are there. There is some hydroxy compound which has a molar mass. The compound has a molar mass of 122. Is acetylated with acetic anhydride using large excess, and new compound, new molar mass, old molar mass is this, new molar mass is 290. Now they are saying we have reacted, we have converted OH to O, C double bond O, CH3. That means O, C double acetylated now. Now see, oxygen and hydrogen are same. That means 2 carbon, 1 oxygen and 2 hydrogen mass. That is 12 to 24 plus 16 plus 2. That is 24 plus 16 plus 2, 6, 7, 8, 9, 10, 11, 12. That is 42. So that means extra mass that we have added is 42. Right? That means one acetyl group will have a mass of what? 42. Right? It's not about one acetyl group added, extra mass for one OH to acetyl group replacement is 42. They are saying extra is, total extra is what? Total extra is final minus initial. That is what? This is 0, 9, this is 7, this is 170. For this it is this, so number of OH group is, how much total extra is 170, and for 1 it is 42. And when you will see this, wait a minute, this I have calculated to be wrong, right? 290, this is 122, this is 10, 2, this is 8, this is 6, 168. 168. 2, 2, 4. 2 into 4 will be this. So answer will be 4 is the correct answer. Okay? Right? Answer will be 4 is the correct answer here. Right? Done everybody? This one. Okay? This you don't need to know what was the group. You just need to know these calculations. That's it. Right? Now let's talk about the next one here. Next is, let's see this picture. Let's see everyone. This they are saying that there is this compound 3,3-dimethyl 2-butanol cannot be prepared by which of the following? Let's see that. So firstly, let's see. This is butane 1, 2, 3, 4. 3, 3. That means here this is CH3, here this is CH3. 3,3-dimethyl 2-butanol. 2 on the second position, you have OH. Right? Cannot be prepared by which? So if you see this here, okay. So one by one we'll look for this. This is alcohol, right? On alkene, when you add this Kirchhoff's reaction, you prepare aldehyde or ketone. So this cannot be, that means E definitely will not form it. So EE. Okay, these two are eliminated. So B definitely cannot form. You don't even have to look for that, right? C, I'll have to see whether it forms or not. If I see C thing here, this will be 1, 2, 3. This is 1, this is double bond O. And this is also 1 methyl. 1, 2, 3, 3 methyl, then this carbon, this is double bond O, then this is 1 methyl, right? 1 carbon, this okay. Now this is reduced. This is reduced with NaBH4, that means you will add here OH. So this is CH3, COH, C3 methyl. So here also you can prepare. So that means C cannot be prepared, that is wrong. C can prepare, so answer will be A, that is B and E is the correct answer here, right? So that's how you answer these things, right? Then the next question is, you have this compound where you are adding CrO3 in excess. CrO3 is actually your compound where what you do here, CrO3 is a compound where you, it is like oxidizing agent. So you convert it into double bond O, and this will be C double bond O, OH. Right? Then 1 mole of this is used. 1 mole of this means, then it is, this is O, this thing, wait a minute, it will be C double bond O, OH, right? This will be 1 mole of this means 1, 2, this is this thing. Then this is Q. And then you react it with Grignard reagent in ether and then you hydrolyze it. You know, again this will be converted to OH here. A double bond O here. Then you do NaBH4 reduction. That will be converted to OH here, right? Then you do NaBH4 reduction. 0.1 mole of on reduction, ester will be again converted, yes. So let me tell you the full sequence here. So basically In this, firstly, this is converted to double bond O and this is converted to COH. Okay. After that, you add this is converted to OCH2, this is ketal. Now, in the cyclic ketal, whenever you add Grignard reagent and you hydrolyze it, right, what will happen? This again gets converted to double bond O and then you reduce it, then it is converted to OH. So, this is going to be your full-fledged compound here. Now they are asking you that what is the percentage, 0.1 of compound S will weigh what? You have to calculate the molar mass of this compound, multiply it with 0.1. Molar mass of the compound S is coming out to be 130, multiply it with number of moles, you will have the mass here. Okay, yes everybody. Now let's see the next question, that is the boiling point of alcohols and phenols increases with increase in number of carbon atoms here. Yes students? Yes everybody? If you see, the boiling point of alcohol and phenols increases with increase in the number of carbon atom. So the boiling point is here because of which thing? Tell me. The boiling point is here because of the hydrogen bonding here, right? Alcohol and phenol increases with increase in the number of carbon. Okay, that is correct. Boiling point of this are higher in comparison to other classes because of hydrogen bonding. That is also correct. So we can say both the statements are correct here, right? First is number of carbon atom increases, the molar mass increases. This in turns increase the van der Waals forces and hence you can say that boiling point will increase. And why it is more than others? Because of the hydrogen bonding, right? Okay. Next question is identify the major product. Only 10 questions left, okay? So, and I'll give you 5 questions for homework as well. Answers will be written here. So you just have to go through that firstly, solve them yourself. You don't have to answer anything in the comments, right? Just solve it for yourself, right? Identify the major product A and B respectively in the following set of reactions. So this is a set of reactions. So in set of reaction 1 and 2, let's see firstly with CH3CO. If I talk about this reaction here, we're using concentrated H2SO4, that means dehydration. This will be dehydrated and here you will have the double bond, or you can say here you will have the double bond, they are symmetrical only. So that's how you will have the formation of alkene, cycloalkene. If I say pyridine here, pyridine means it is going to take away H positive and it will be converted to O negative. And when you add CH3COCl here, this whole thing will attach here, so it will become OCOCH3 and that is going to be the answer there. Okay, so answer is B is the correct answer. Now let's see the next question here, everyone. The next question here, Grignard reagent. Now this is also, as I told you, in JEE 2026 they have asked these kind of questions. So you can see Grignard reagent RMgX or Br reacts with water and form a gas. Okay, see one thing, whenever Grignard reagent reacts with water, it always form RH and here MgBr, H positive and this will be OH negative. So you'll have MgBr and here you will have OH also. Okay. Forms a gas Q. 1 gram of Q occupies 1.4 decimeter cube at this. 1 gram occupies this volume. P on reaction with dry ice, P is this compound with dry ice, in dry ether followed by hydrolysis gives compound Z. So whenever we talk about Grignard reagent reacts with dry ice, we talk about acid. This is positive, this is negative, it attacks here, it is electrons will shift here. So RC double bond O, this is OMgBr. After hydrolysis, it is going to give you this thing. Right? Now let's see they are asking you 0.1 of Z will be what? First, you have to think about R here, right? This much reacts with water to form a gas Q, right? Now, if I say this reacts, this will be your gas Q, isn't it? This will be your gas Q. Now, ethane does not exist as gas. Methane exists as gas. So that means if this is the gas, this for sure they are talking about methane. That means if this is methane, that means R is equals to 1 carbon, that is CH3, that is also for sure. That means this is CH3 MgBr. That means this is nothing but CH3 COOH that is formed. So now from just one hint, everything is clear. Right, now let's see about the masses here. If they say that 0.1 mole of this will weigh what, you don't even have to do anything, right? Even if you do this much, that number of moles of Z is 0.1 and molar mass of Z will be 2 into 12 plus 2 into 16 plus 4, that will be molar mass. So M of Z will be number of moles of Z and molar mass of Z, multiply it and you will get your answer here. So this much also you don't have to do, even if you directly do it like this, that the molar mass is 60, okay? This much is also not needed here, okay? This much is also just to confuse you, right? So by this only you will be able, to get that what is the thing, right? So after this you can say molar mass of Z is going to be, number of mole is 0.1, this is 60, that is 6 gram, okay, right? Chalo. Now let's see the next question, the correct order of acidic strength here. Now these are they are saying that you have to solve all of them, then also have to tell the acidic strength, reactions also, and then acidic strength. Two questions mixed, and reaction also 4 type of reactions. So see this. This is aniline. With this it will form disonium chloride, right? Disonium chloride with this will form CN, and CN after hydrolysis, complete hydrolysis is going to get converted to COH, right? CN after complete hydrolysis gets converted to COH. What about this one? Here it will give you CH3, CH2, directly COH it will be converted to. This molybdenum, that means ethanol, wait a minute. You have O2 and molybdenum oxide you have, right? Then after that you are reacting this with Na2Cr2O7, that is supposed to be yes, right? So when you have this thing here, this will be converted to same number of carbon acid, okay? Then you have MgBr, this will give you what? This is phenyl pH, CH2, here this will give you C double bond OH, this thing, right? So here they are saying that you can write it as phenyl CH2 C double bond OH. Now once you have these 4 things, right? Once you know that these are the 4 answers that I have, now you have to tell what is the acidic strength here. So how do you tell the acidic strength here? Definitely benzoic acid, because of resonance stabilization it is going to give like maximum this, right? So benzoic acid is going to be maximum, so A is going to have maximum acidic strength here, right? So here all of these are, in these cases you will have plus I, here you don't have any plus I, here you have plus I. Basically this is not directly resonance now, so benzene is also one step away from this. So you can say this, in this case you have donation, here you don't have donation. So after A you have D, then out of B and C, right, which one is more? Here you have donation, you don't need donation, so C is more acidic, right, as compared to B. So answer should be B is the correct answer here. Wait a minute, why so? Oh, benzene. Yeah, I'm so sorry. We forgot about one thing here. We forgot about this thing that this HCOH, if you see this HCOH, this is going to be most acidic. Why? It is going to be most acidic because it has equivalent structures, right? So it is going to be most acidic here. That is correct. So answer is methanoic acid is most acidic, right? So this is maximum. Then you will do the reverse here. Firstly will be C, then there will be A, then there will be D, then there will be B. Everything else is correct here. Just C has to be most acidic because of the equivalent structures that it is forming. Okay, right? Done. Chal. Now let's see the next one. Given below are 4 compounds here. 4 compounds. They are saying 4 statements are given to you and they are asking you the correct statements here. Yes, the correct statements out of them. Tell me everyone, what is the correct statement out of them? Yes, students, the correct statements here. Which one you are not able to understand? This one, beta, I just forgot to mention one thing here. See, wait a minute. See, first you will have to do the reactions. I just skipped one thing. I think that's why you are getting confused. HCOH is more acidic than benzoic acid. Okay, HCOH is more acidic than benzoic acid. That's it. That's all I wanted to tell you, that HCOH is more acidic than benzoic acid. After this you have A, then you have D, then you have B. That will be the answer here. Okay, acidic strength you have to tell here. Now let's see this one, the correct statements here, that is QRS will give precipitate with 2,4-DNP. 2,4-DNP is given by carbonyl, so you need to have carbonyl. This has carbonyl, this has carbonyl, this has carbonyl, so they will give this test, right? P and Q will give positive Beer's test. Now tell me, for Beer's test what you need to have. For Beer's test, P and Q, that means you need to have double bond here, right? So here you don't have double bond, is only here. This will give positive test Beer, this will not give positive Beer test. So this is false. Only P will give positive Beer test, right? Then Q and R will give sooty flame. Q and R, if you see this here, they are aldehydes, so that's why they are going to give the sooty flame here. That is also correct. Okay, R and S will give yellow precipitate, that means iodoform. R and S, this is methyl ketone, this is not methyl ketone, so this will not give you iodoform. So iodoform is given by only R here, right? Only R, this will not give, right? Then you have Q alone will deposit silver with toluene. Now silver test means out of this will deposit silver. See, for that you need to have aldehyde. Aldehyde is here, this is ketone, this is also ketone. So yes, this alone will give you tolerance test, that is also correct. So answer is A, C, E is the correct answer, that is D will be the correct answer here, right? Okay, chal. Next question is cross-aldol condensation. Now these are the statement based question. I think you can easily answer this. Tell me everyone, what about this question here? Tell me. So cross-aldol condensation between two different aldehydes will always produce 4 different products. No, they can produce more than 4 as well. They can produce 8 as well, depending about how many alpha it has, right? So this is all false. They can produce more than 4 as well. When semicarbazide reacts with mixture of benzaldehyde and acetophenone, okay, under optimum pH, it forms condensation product with acetophenone only. No, it will form with both. Because see, in benzaldehyde also, you only need to have carbonyl group. So this semi-carbazide will react with benzaldehyde also, and even if you have acetophenone, that means C double bond O CH3. Because it is only looking for C double bond O, that means this statement is also false. So both are false here, right? Okay. Next is compound P undergoes following sequence of reaction. Compound P is there. It is undergoing following sequence of reaction. Okay. See, firstly NH3 and you heat it, something you have here. Where you add this, I can say this is Hoffman. If this is Hoffman, then this definitely should be CONH2. If after ammonia and heating you have NH2 here, then I think this should be COOH. Right? Then only you will get amide, then only you will get Hoffman. And with Hoffman, you will have NH2. And after NH2, when you do carbylamine, this will give you NC. Acha. There is no benzene here. This is cyclic. Okay. Then my mistake here. This should be no circle here. Right? That means it is cyclohexane only. Right? Then you will have this as the answer. Acha. Now what they are asking you, what is P? P is going to be this. A will be the correct answer here. Right? Okay. Next is only 5 more questions left. Okay, let's see. Identify the structure of final product D in the following sequence of reaction. Tell me what is the product D? How many total sp2 hybridized you have here? Anyone of you? Anyone of you? Let's see. pH, C double bond O, CH3 you have. You add PCl5 here. In these cases, this is a halogenating reagent. So this will break two double bond O and it will be converted to CCl. Now I add 3 equivalents of NaNH2. Now in 3 equivalents of NaNH2, what you will have here, with 2 equivalents of NaNH2, this will be dehydrohalogenation. 2 halogens eliminated, 2 hydrogens eliminated. This will give you PC triple bond CH. Then again you add here NaNH2 and ammonia. This will give you P acidify. Acha. It will make only this thing. This will NaNH2, then you acidify it. It will then you do hydroboration. So let's jump to this thing only. Acidify means Na will be converted to H here. Right? So I am just directly doing this. This will be pH, C triple bond C. There will be one bond will break. This will be OH here and this will be H here. Then this will be tautomerized to pH, C, H. This is hydrogen is placed here. This is C double bond OH. This is C double bond OH. Okay, C double bond OH. Now they are saying that the number of sp2 hybridized. So this is the final product that you have. Okay, this is just to confuse you. This is just to confuse you. Firstly, they are saying add one extra NaNH2, then acidify it. They are saying that firstly convert it into Na, then again convert it into H. Right? That is like you can, like extra step just to confuse you they have given. Now here, what is exactly this? You have 6 plus 1, that is 7 sp2. So answer will be 7 sp2. 6 is in phenyl and 1 is in this C double bond O. So answer is 7 is the correct answer here. Got it? Okay. This will be very wait a minute. Okay. Done. Now let's see next one. Consider the following reaction sequence. Again reaction sequence is there. Concentrated HNO3, concentrated H2SO4 is there. Then they are saying SN, HCl. Okay, so many things are there. So concentrated this and this and this. Firstly, it will give you nitrating mixture. That means this will give you NO2. Then after that, you are going to add SnHCl. That means this will be converted to NH2. Then after that, you are doing acetylation. That means this will be converted to NH, C double bond O, CH3. Then you are again doing nitration here. That means this will be converted to NHCOCH3. On the para, you will have NO2. Then you are doing again adding this here. So it will be, this is NH, this will be converted to NH2. This will remain NO2. Now, this is the final product that you have, right? That is T. So they are saying percentage of nitrogen in T. So what is this? So here you will say, let's say percentage of nitrogen will be 28, because 2 nitrogens you have divided by molar mass of T multiplied by 100. That is going to be the correct answer here, right? This also I have told you, right? This is the calculation that you can do. Molar mass is coming out to be 138. 28 by 138 multiplied by 100 is the correct answer here, right? Okay. Last 3 questions. Let's do that. Total number of alkali insoluble solid sulfamides obtained by given amines with alkali insoluble means you will have to look for 2-degree amines. That's it. Just see how many of these are 2-degree amines and that will be your answer. Yes, everybody, just see how many of these are 2-degree amines. Let's talk about that. How many of these are 2-degree amines, and that will give you your answer. Aniline is 1 degree. N-methyl aniline. This is 2 degree because this will be, I'm just drawing those structures which are 2 degree, okay? This is NH, N-methyl means this thing. Methanamine. Methanamine means CH3NH2. This is 1 degree. N dimethyl. That means 2 methyl, and then third is also methyl. This is 3 degree. This is 3 degree. This is 1 degree. This is 2 degree. This is also 1 degree. Okay. So till now there is only one here. Then N-methyl methanamine. In amine you have 1 methane and 1 M-methyl. This is 2 degree. That means on nitrogen there is 1 CH3 here, 1 CH3 here, and 1 is this one. This one is 1 degree. Yes. Then phenyl methanamine. In methanamine you have 1 phenyl. That is also 1 degree. Right? Because on phenyl, on nitrogen you have 1 phenyl, 1 methyl. Right? Okay, that is 1 degree. N-propyl aniline. This is also, this was 2 degree, na? Wait a minute, so sorry. This is 2 degree. This is also 2 degree. I am writing 1 degree. N-propyl aniline. That means on this you have N-propyl. That means C3H7. Okay, so that is also 2 degree. N-phenyl aniline. That is also 2 degree, right? N dimethyl, this is not. Allylamine is also not. Isopropylamine is also not, right? So here one is N-methyl aniline, okay? Then there is N-methyl methanamine, okay? Then there is phenyl methanamine. Okay, then there is N-propyl aniline and N-phenyl aniline. So mine is coming out to be 5. So we have 2 degree amine, na? 1, 2, 3, 4. Why mine is coming out to be 5? One is this one. One is N-methyl aniline. We have not taken N-methyl aniline. This is propanamine. Wait a minute. How many I have taken? They have not taken N-methyl and 5 should be there, na? How many you are getting, or 4 should be there? This is this thing, and if I see this is dimethyl, NN. Acha, this is NN dimethyl. Okay, this should not be there. This is also not there. Then this is N-phenyl. Mine is coming out to be 5 here. I don't know how. N-phenyl means here it should be phenyl. So 2 phenyl are there, right? So 2 phenyl they have taken it here. Yes, 2 phenyl they have taken. Even I have taken. Then 1 propyl wala also I have taken. Even they have taken. They have taken 1 phenyl, 1 methyl. They have taken it. Even I have taken 1 phenyl, 1 with. Acha, this is same. N-phenyl aniline and N-methyl aniline. N-methyl. Then where is the mistake going on? N-methyl aniline. That means 1 methyl. Or this is, this one is, yes, some mistake is going on. Okay, these two are same only. That's so bad. Now what is this, huh? What is this, bro? These are same only. If you see, N-methyl aniline and N-methyl methanamine, sorry, not N-methyl methanamine and phenyl methanamine, because phenyl methanamine also same and this is also same, so in total you have 4. That is so bad, so bad. Same thing 2 times. Okay, very bad JEE. Right, now this so confused me as well, right? So yes, now let's see these 2 statements here, right? Yes, everybody, now let's see these 2 statements here. Let's see if you're able to tell me the correct answer here. This can be synthesized from this using simple reagents in the order acidic KMNO4. Okay, if you use acidic KMNO4, this whole thing will be converted to COOH, COOH. Then you use ammonia. Ammonia means then this will be converted to amide, CONH2, CONH2. Then Hoffman bromamide degradation means this will be NH2, this will be NH2. Absolutely correct. This statement is correct. You can do this. This can be converted to this using these reagents. So let's see. You have this as the CH3. Firstly, you do bromine water you use. When you use bromine water, right? That means you will have Br, because bromine water means bromination will be there. Now NH2 is highly activating, so it will ortho and para. Para is already occupied, so ortho positions will be there. After that, you add NaNO2 as they have mentioned here. This will be converted to, now see, this thing will be converted to disonium chloride here. Now we can easily see this statement is also correct. Then after that, you aqueous H3PO3 means this will be converted to hydrogen. So this statement is also true. So both the statements are correct here. Okay. Very nice. Now let's see the last question of today, that is an organic compound P on treatment with aqueous ammonia under hot condition forms Q. With aqueous ammonia under hot condition, okay, some organic compound is there, which on heating with this and this. So from this and this, it is clear that the Q that it is getting formed must be CONH2. Only then on reacting with Br2 and KOH, this is giving rise to NH2, which is the compound R, having molecular formula C6H7N. That is correct. So that means P must be here, P must be COOH, right? Now you have PQ. Now we are saying that What is PQR respectively? Tolic acid, methyl benzamide, 2-methyl. This is C6H7, 567. Huh? So this is not correct. Benzoic acid, benzamide and aniline. B is the correct answer. So answer will be B is the correct answer here. Okay, everybody, tell me. Tell me, everyone. Acha, now I am giving you some extra questions here, right? For your homework, right? Some extra questions, and this is you are supposed to do yourself, right? 50 questions I promised you. 50 questions we have done, right? Now we will do, like, not we will do, you will do this. So I am giving you this one question here, 2025 question. Again, answer is already given to you so that you can, easily do. But still, if you have any problem, you can ask me. This is the second question regarding test and all, right? Then you have the third question here. This is sequence based question. Again, answer is given to you here, right? So that you can see that what will be the correct answer. Then fourth question, right? Again, answer is here also given to you, right? So 4 extra questions I am giving you. If you have any problem regarding these questions, you can answer me. You can ask me. Okay? 4 questions I am giving you. Do it yourself. If you have any problem, you can ask me. Right? Okay? Yes. Bacha, definitely, Tanisha, I'll also take classes for advanced. Now, wait a minute. Now, what we are going to do, we are going to go, and tomorrow at 12 p.m. I'll take your class, because if I take tomorrow in the evening, you will already be in so much anxiety that you will not be able to focus only, right? So that is why I know evening also I'll take one session. That will not be academic session. We'll talk. We'll understand that what should be your mindset in the exam, right? We'll just talk. If anything you have in your mind, we'll talk, right? So that session is going to be 7 p.m. You tell me whether that session should be 7 p.m. or 8 p.m. whenever you are all of you are there, right? I am to here only for you, right? I'll take that session tomorrow, right, at 12 p.m. regarding top 30 questions from inorganic, organic, and physical. And these are top sure short questions. So see you all in the class tomorrow at 12 p.m. Till then, bye bye, take care, and also tell me in the comment section that have you done these 4 questions or not. Till then, bye bye, all the best, bye bye.